When we talk about combining different equations, we have to be careful about what the domain of our new creation is, all right? So we've made this new equation. What values of x are allowed to go into it, all right? So the general rule is for an element to be in a combined function, it has to be in the domains of both original functions, all right? It can't just be in one, it's got to be in both. So there are some exceptions to this. If I were looking at this function f of x and this function g of x, and I wanted to form f divided by g of x, well, I would have x squared plus 1 on top, which is f of x, and then g of x would go on the bottom, and 3x plus 5. Now, if I'm looking at each of these functions individually, the domain of f of x is negative infinity to infinity. There's no number that, oh, that's a weird looking infinity. Let's do better. There's no number that I can't square. There's no restrictions on f of x. Similarly, g of x's domain is also negative infinity to infinity. There's no number that I can't put in for x. But when I combine them with division, all of a sudden I've created a problem because I have something in the denominator. And when I put something in the denominator, I am creating a situation where I could divide by 0. So I have to say that this domain of my new function, I'll write it in two notations. I'll write it in set notation. All right, the domain of the new function is all the x's where x can't be negative 5/3, because that's the value of x that makes the denominator 0. In interval notation, we would say it's all numbers up to negative 5/3, but not including it, and then joined up with all numbers from negative 5/3 to infinity. Okay? So now I have three functions. I have h of x, j of x, and k of x. So if I'm going to find the domains for each of these, I'll say that the domain of h of x, all right, h of x is just a line, 2x plus 4. So that domain is negative infinity to infinity. No problems there. The domain of j of x, is similar here because this is a parabola. There's no number I can't square. So that domain is negative infinity to infinity. All right, the domain of k of x is a little more complicated because I have a square root and I'm not allowed to take the square root of anything less than 0. So in order to find that domain, I have to say, well, 3 minus x has to be less than, I'm sorry, not less than, it has to be greater than or equal to 0 because anything less than 0 wouldn't work. So my domain for k of x is going to be all x's less than or equal to 3. Okay? So now I have domains for each of my functions individually. When I start combining them, I have to be careful. So if I'm going to combine j over h of x, well, j of x is negative x squared plus 8. H of x is 2x plus 4. And so this is j over h of x. And normally both of these domains are all real numbers, both h and j, but I have to account for this denominator here. So the domain for this combined function is all real numbers except for the value that makes the denominator 0. So negative infinity, the value that makes the denominator 0 is negative 2. So I'm going to exclude that from my domain. I keep going negative 2 to infinity. All right. So if I switch those and I have h over j of x, well, it's a similar idea. Now I have 2x plus 4 in the numerator and negative x squared plus 8 in the denominator. The value that makes the denominator 0, it's a little more complicated, not much though. You end up getting negative x squared plus 8 equals 0. To get x squared equals 8 when I subtract and divide. So x equals plus or minus the square root of 8, which we can simplify the square root, 2 times the square root of 2. Okay, these two values, plus or minus the square, plus or minus 2 square roots of 2, those are the values that make that denominator 0. So if I'm going to come and write my final domain, okay, I'm going to write the domain. I'll go ahead and write it in interval notation, though it's a little bit longer in this situation. I'm going to say the domain of h over j of x is negative infinity. First comes negative 2 root 2. We have to exclude that. And then everything in between negative 2 root 2 and positive 2 root 2 is fine, but we have to exclude the positive 2 root 2. And then everything from 2 root 2 to infinity is fine. Okay, so there's 3 intervals. I've excluded 2 values there. Finally, let's look at h over k of x. So h of x is 2x plus 4. K of x is the square root of 3 minus x. So we know that the entire domain is limited now to the domain of k of x. The domain of h of x is all real numbers, so we're really not worried about that. But the domain of k of x is going to be our limitation. So we're going to say already we know that this is the biggest that the domain can be. We have a complicating factor in that this square root is on the bottom. So now x can't be less than or equal to 3, it can only be less than 3, because if it were equal to 3, then I would have 0 on the denominator. Okay, so I'm starting with my most restrictive domain, which is this k of x domain, and I'm saying, are there any other restrictions that I have to add in because I've formed this combined function? And the other restriction I have to consider is whatever this denominator is. Okay, so my domain in interval notation is all the numbers from negative infinity up to, but not including 3. That's that final domain. Let's look at this if I have 2 square root functions. The domain of s of x, all right, if I'm looking at this first square root, if I say everything in here has to be greater than or equal to 0, I know that x has to be greater than or equal to negative 6. Okay, and if I'm looking at the domain of r of x, I know that x has to be less than or equal to 4. Those are my 2 domains, okay? If I'm going to combine these 2 functions together, right, if I'm looking at this s plus r of x, what I have is the square root of x plus 6 plus the square root of 4 minus x. My domain is limited to the domains of the 2 functions that I just combined. So the domain of this new combined function is going to be all x is greater than or equal to negative 6 and all x is less than or equal to 4. So I have all the numbers from negative 6 to 4 inclusive, but nothing outside of it, because then that would be outside of r of x, and nothing nothing greater than 4, because that would be outside of r of x, and nothing less than negative 6, because that would be outside of s of x. So this is my combined domain. I have to take into account both functions. All right, and finally, let's look at some graphs. I have 2 functions here, they're both lines. The domain of f of x is, what do we have? Negative 3 to infinity. The domain of g of x is going to be negative infinity up to positive 3, not included. Okay, so now, oh, I did both at the same, haha. All right, we'll put g of x where it belongs. G of x is, what did I just say? Negative infinity, and then I'm going up to 3, not included. Okay, so now if I'm going to multiply these 2 together, I'm combining these 2 functions, so I have to combine both of their domains. I have to say that f of x has to be greater than negative 3, and g of x has to be less than positive 3. So if I combine those 2 domains together, I get that the function combined has to go from negative 3 included to positive 3 not included. All right, those are where those 2 domains overlap, and those are the only numbers I can pull from to go into that combined function. So, for example, if I'm finding f times g of negative 3, I'm saying f of negative 3 times g of negative 3. Well, f of negative 3 is 4. G of negative 3 is negative 3, and 4 times negative 3 is negative 12. All right, if I'm finding f minus g of 0, well, I'm finding f of 0 minus g of 0. All right, f of 0 is 3. G of 0 is a negative 1, so 3 minus negative 1 is 4. And in order to understand why this combining functions is a thing, let's look hypothetically here at f plus g of negative 6. All right, well, if I'm finding f of negative 6 plus g of negative 6, g of negative 6 is down here. That's negative 5, but I run into a problem because f of negative 6 does not exist. It's outside the domain of f of x. So I can't do f plus g of negative 6 because it is not in my combined domain. All right, it is outside of the domain for at least one of the functions, in this case f of x. So this is a problem that we can't do. We would say it has no solution. Okay.